Now the bench is a pretty substantial thing. You need a vise that you can put the saw in that is straight, it doesn't wobble. You can tilt it to do various aspects of the filing process. It needs to be a good height. The height that I like is to have the top of the vise about elbow height when I've got my elbow bent at a right angle like this. You need to have very good light, especially for pointing up the cutter teeth, because you'll need to be able to see reflections off of those teeth. And the reflections that we're talking about are quite minute, so you need very good light. And traditionally, the filing room was set up so that you have, facing the filer, you have a bank of windows, generally facing north, so you get good diffuse skylight. And often they'd end up also having true skylights that illuminate from the top. If you don't have a situation like that where you have a good north-facing skylight, what you can do as a substitute is use like an 8-foot fluorescent light or 2 4-foot fluorescent fixtures and put them up on the wall, say 7 feet off the deck or off your floor, so that the light comes in at a nice angle to be able to reflect off of the flat spots which are created by the jointing process, which is what I'll talk about next. One of the things that you may notice about this bench is that there are a number of holes that I have drilled in here, and the purpose of those is to be able to adjust the height of the saw to hold the saw at a particular height. What I do is in each of the holes I just put a 3/8 inch bolt, and there are some operations that I want the saw fairly high, like this, and there are other operations that I want to be able to have the saw lower in the bench like this, and so I use the bolts to hold that. Another reason for using something fairly substantial like these bolts is that when I swedge the saw, which is another one of the processes I'll be describing here, you're hammering on the saw and you need something to keep the saw from being driven down into the bench. I hold the saw with these thin oak slats that are tensioned so that they hold the saw firmly, but at the same time they don't hold the saw so tight that I can't lift it in and out, or if I need to move it sideways like that. Another thing that you may notice on this bench is that I've got black tape on the top of this, and that is so that I can see the light that's coming off of the teeth better. It gives me a better contrast between the light that I see on the tips of the teeth and the background, which enables me to see the progress I'm making on the tooth better. You know, it's good to have a tool tray where you can put your various tools. As you can see, you've got quite a number of different tools to use. Now, the orientation of this bench for most of our operations will be vertical like this. When you joint the saw, when you fit the rakers up, and when you set them, but when you're actually pointing up or sharpening the cutter teeth, then the bench will be tilted at probably around a 45-degree angle, something like this. It's much easier to file a bevel on the tooth, and also with your light source coming in at say a 45-degree angle and hitting those flat spots that were created by the jointing process, it makes it so that you can see the reflection off of the tips of the teeth much easier. And this is very critical to be able to clearly and distinctly see the flat spot on the tooth that was created by the jointing process. Before we actually go into the section on adjusting tools, we need to talk a little bit about why we're adjusting the tools to the adjustments that we are making. The adjustments on tools will be a function of a number of different things, including the type of wood that we're working with, the weight of the saw, the size of wood. All of these have an effect on the adjustment. And in the final cut, how you adjust the tools is going to be a function of how well your saw is working in that particular wood, in that particular situation. But I can give you some rules of thumb here. For a felling saw, which is a fairly light saw, the way I end up adjusting the raker gauge is such that the rakers are about 12 thousandths of an inch shorter than the cutter teeth. And I use the same numbers with the spider. I set up the spider to where there's about 12 thousandths of an inch clearance between the spider and the flat that I'm using to gauge it by. Now a heavier saw, like this bigger bucking saw, I'll use quite a different raker depth. Instead of using the 12 thousandths like I did with the felling saw, I'll adjust my rakers to where they're about 16 thousandths of an inch shorter than the adjacent cutter teeth. And the weight also affects how much set you put in it. Rather than the 12 thousandths like I would put in with the lighter weight felling saw, I put about 16 thousandths of an inch set in the cutter teeth. You know, that's a good starting number. The real test is taking it out and putting it on a log and actually running it. And if the saw binds, it means you don't have enough set in it. If your saw pulls shavings with whiskers on it, and we'll talk about that later, you know your rakers are a little bit too long. If the shavings are real thin and papery, it means that your rakers are actually cut too short. There's three primary tools that we're working with in filing a saw. One is the pin gauge, another is a raker gauge, and the third is the spider, which we'll talk about here in a bit. I'll talk about how to adjust the pin gauge first. The pin gauge, we have a pin right here, and that sticks down below the level of these two plates here a certain distance. And for a good average crosscut saw, what I'll do is adjust this pin so that it sticks down below the level of these two plates by about 9 thousandths of an inch. Now, how to get 9 thousandths of an inch there's various ways of doing it, but one fairly easy way, if you don't have any other measuring tools besides a feeler gauge, is to actually use a saw tooth. Now I have a tooth here which has been prepared for swedging. The height of it is about the height of the two cutter teeth on either side of it. And so what I'll do is I'll swedge that tooth over to where it's about 9 thousandths of an inch below the straight line between your two adjacent cutter teeth. So I'll just go ahead and swedge it over some. And then I need to measure the height of that. So I'll do that with a flat piece of steel and a feeler gauge. I'll put the feeler gauge on there, put the flat on the two teeth adjacent to the raker, and see how much I've swedged it over. Well, the raker, or the feeler gauge, is still the tooth is still so high that the feeler gauge is hitting the tooth. So I'll need to swedge the tooth over some more. Okay, I've got a tooth here that I've now swedged over to 9 thousandths, to where this raker tip is 9 thousandths of an inch shorter than the line between these 2 points here. And I can test that by putting the 9 thousandths feeler gauge between my flat, and it just clears that raker tip. Now I use this as a reference to check or to adjust the pin gauge. So what I'm doing now is I put the pin gauge on here and I adjust the height of the pin as I move it back and forth until it just hits that raker tip. So now I know that the pin is adjusted at 9 thousandths. Now while I'm holding the screw tight, or the pin, I lock this down so that it doesn't move. I test it. Well, it moved up a little bit, so I need to screw this down just a hair so that it touches the tip. There. Okay, that's just barely touching the tip of that raker. Now I lock it down tight and make sure that it doesn't move anymore. I can just barely feel that touching. So now we have the pin set at 9 thousandths of an inch below the two support plates. The raker gauge that I used on this saw was one that I'd built myself, and there aren't very many of them around, but I'll show you how to adjust that, because the adjustment process for this will apply also to other sloped filing plate raker gauges, of which the Anderson gauge is an example. The plate that I actually use to adjust or to dress the raker point on a slope filing plate raker gauge obviously has a slope to it like this. So in order to adjust my raker gauge using the raker tip which I had originally used for adjusting the pin gauge is fairly easy. We've swedged this raker tip over to 9 thousandths so that the pin gauge will just clear it. Now, the raker gauge should be adjusted about 3 thousandths below what the pin gauge is adjusted. So I can adjust my raker gauge by putting the raker gauge on the saw just like I would use it. And I'll take two pieces of 3 thousandths feeler gauge, put one under one side between the support plate and the adjacent tooth, and another one under the other side. Now, if I adjust the height of my raker gauge here to where the file just touches the tip of that tooth, okay, we're not touching there. I'll drop it down just a little bit. Okay, that's too low. So I adjust the height of my filing plate until the file just touches that raker tip. I'm doing this primarily by feel. Okay, it's not touching there, so drop it just one notch. Okay, we're just barely touching that tooth. Now I know that the raker gauge filing plate is adjusted to where it's 3 thousandths of an inch below where I have the pin gauge adjusted. And that's just what I want, because when I'm using the raker gauge, I'm putting it on the tooth, on the raker tip. I want to make sure that there's enough of the raker tip sticking up above the filing plate that I can file it off and dress that tooth the way it's supposed to be. Now, the Anderson gauge essentially is the same thing. You put that on the tooth, you put the feeler gauges underneath the plates, and there's a little screw in the top of the plate that you can move used to move this plate up and down, and you use exactly the same process of running the file across the filing plate until it just barely touches that tooth. And you know that the filing plate is adjusted for being 3/1000ths of an inch below where the pin gauge is adjusted for the swedging purposes. Now, the most common Raker gauge that you'll run into is one like this. It's called a Morin gauge. This particular gauge and many similar to it have a flat filing plate on it, and this gauge here is quite easy to adjust. The filing plate on it is held on with 2 screws so that you can undo these 2 screws, loosen up the filing plate so that it moves, and then to adjust it, all you have to do, if you want your filing plate to be adjusted for 12/1000ths, all that's necessary is to put a piece of 12/1000ths feeler gauge between the filing plate and the rail, these 2 rails or plates here that rest on the teeth, and then tighten the filing plate back up. And so doing means that the filing plate will be the thickness of the shim below your 2 adjacent cutter teeth, and automatically adjust the proper height of your filing plate. There's another gauge called a Simon's gauge, which actually has a ramp that the filing plate moves along. So that as you move the filing plate up or back and forth, the height of the filing plate changes, and the adjustment is very similar. You can put a piece of 3/1000ths feeler gauge on the top of each of the adjacent cutter teeth and adjust the filing plate back and forth until when you go across the filing plate with a file, it just touches that reference tooth that we originally set up for use with a pin gauge. Now, for a raker to function efficiently, the trailing surface of the raker tip needs to have a sloping clearance angle. This enables the raker to penetrate the wood and not ride on top like a sled. Now, this is accomplished automatically with a sloped filing plate. However, if a flat filing plate gauge is used, the clearance angle needs to be established by carefully dressing the horizontal surface left by the file so that it slopes, providing a clearance angle. Care needs to be taken when you do this so that the raker tip is not over-filed, which would result in a shortened raker. Okay, the next tool we're going to adjust is the spider. The spider is used to measure the set on the tooth. It's a fairly straightforward process. You have basically a flat surface that you use as a reference. You put the spider on the flat surface, and the spider should rock around the short legs between this long legs here so that you can see it rocking this way. And the adjustment on a spider is accomplished by changing the space between the tip of the spider and the flat. Now, if I, for example, wanted a spider that was set up for 12/1000ths, what I need to be able to do is put a 12/1000ths feeler gauge underneath this spider tip while I'm holding these 3 tips firmly on the flat. This is set up for a little bit more than 12/1000ths. The 12/1000ths feeler gauge slides under it quite loosely. To adjust the spider, you use a stone. I'll just put the stone here, and in order to take some set out of it, I'll take a little bit of length off of the 2 short legs there, just by grinding back and forth on the stone. and then I'll check the adjustment on it with the 12 thousandths feeler gauge. Well, I actually took too much off of that, just a little bit. In order to adjust it so where there's a little bit more set on it, I actually take material off of this end because this is a short leg and this is a long leg. If I take 1/1000th of an inch off of here, it actually changes the setting of the spider by 2 thousandths. And now the feeler gauge just fits snugly under that tip of the spider. And so this spider is now adjusted to 12 thousandths set, and we're done adjusting that spider. Okay, what I'm going to talk about here now is cutting a saw off. There's several different situations where you might want to cut a saw off. For example, if you have a broken saw with a ragged end, you want to cut it off to square that up, and then you'll need to repunch it. Or in this particular instance, what I'm doing is taking a 5.5 foot saw and cutting it down to a 4.5 foot saw by cutting one raker and the end teeth off so that I leave cutter teeth at the end. I'll cut that section off of each end, which will shorten it up to a 4.5 foot saw. So what I'll do is actually lay the saw on a straight edge like this so that the ends of the saw are on the line. You notice with a curved saw like this, the center of the saw is actually away from the curved line. What I want to do is make sure that the cut that I make across the saw is perpendicular to the axis of the saw, so that when you put the handle on it, you'll be able to sight down the handle if you're doing falling and use that as a gunning sight. So to mark the saw, I'll just take the square, lay it up against the table, and make a mark just about in the center of that gullet there, so that this mark is perpendicular. And then I'll put on goggles and ear protection because this is quite loud. My gloves. Now I've got a box here to support the saw, so it's flat on the saw table here. I'll clamp the saw in the vise. Check to see that it's lined up properly, and then go ahead and saw the saw off. Now that I've cut the one end of the saw off, I'll flip the saw over and cut the other end off that I had previously marked the same way. Just check, make sure I've got it lined up, make sure that it's square, tighten it down, and here we go. Okay, now that I've got the saw cut off, what I need to do is take these burrs off the end, which I'll do over on a grindstone, and then I'll come back and we'll mark it for punching holes in it. Okay, the next thing to do is to actually punch a hole in the saw, and what I've done is build a hole punch out of the ends of a saw that I actually cut off of a saw, just very similar to what I just now did. And to locate where I want to put the hole, I'll actually take the end of a saw and I'll get my distance lined up using the existing hole. I'll put a mark there, and I know I want the hole about here. So now what I've done, I'll set the gauge up over the mark that I put on there. I'll clamp it with a pair of vice grips. And then this is the tool that I actually use to punch the hole with. Okay, once I've got my guide set up, I'll go ahead and put gloves on, because the next thing I'm going to be doing is hitting this thing with a hammer. And I need to lay this end of the saw flat on the anvil. Come up a little bit. And with the punch, which is this is actually a 5/16 inch pin punch, which is just a slightly amount smaller than the diameter of the hole that's in the guide. And I'll take a hammer, it's a 3.5, or this says 4-pound hammer, and give it a good strike with the hammer. If I don't hit the punch quite hard enough, the hammer will actually bounce back. If I hit it just right, the hammer will essentially fall dead, just like a dead blow hammer. And we should punch that slug right out. Okay, that punched the hole. Now getting the punch out sometimes is kind of interesting. Okay, that came out pretty well. I actually didn't punch the slug clear out. You can see that the slug is still in there. So now I need to get rid of that slug, and to do that, I actually put the slug over one of the holes here, take a big spike, put it down on the slug, and then it should just come out fairly easily. Okay. And there we have a hole. I want to talk now a little bit about saw patterns, tooth patterns, and things to look for when you're purchasing a saw, especially a used one. This particular saw here is a felling pattern. The characteristics of a falling saw are that it has a curved back, making it thinner from tooth edge to back, making it lighter, easier to use. This is a 4-peg and raker saw. It's got 4 cutter teeth for each raker. One of the characteristics of the older saws, the better made saws, is that they are thinner on the back than they are on the tooth edge, making it so that the saw won't bind if the kerf is closing up behind the saw. This next saw that I'll show you, this is a bucking pattern. Essentially the same saw as the falling pattern, with the exception that it's a little bit thicker metal, and it's quite a bit thicker from the gullet to the back, because the back itself is straight. This is pretty characteristic of bucking saws. They're heavier, making it better for the bucking process, because the weight of the saw is used to facilitate the sawing action. This next saw is a falling pattern, also known as a ribbon saw. The primary differences and characteristics between this saw and the two that we've just looked at is that it's called a perforated lance tooth. Each pair of teeth has a bridge between them, which is used for stiffening the tooth so it doesn't vibrate as it goes through the wood. You want your teeth following each other very closely, and so the stiffness that's afforded by the bridge makes that a lot better. This next saw is a one-person pattern. The saws that I've shown you so far are 2-person. although each can be used by one person, but they're easier to use with two people. The characteristics of this particular saw is that it's asymmetric. You notice that it's much deeper from tooth to back on the handle end than it is on the off end. This particular saw has what's called a stinger handle or a helper handle on it, so that when a person is using it, you can actually use two hands on the saw. If you have two people who are wanting to use the saw, you can take this handle off and place it in the hole down here at the other end of the saw, and then you have a helper handle so that two people can use it. This particular saw has 2 cutter teeth per raker, which is more characteristic of saws built for hardwoods or frozen woods, often used in the Midwest and East Coast woods. Okay, that's a basic overshot of the saw shapes and patterns. Now I want to talk just a little bit about characteristics to look for when buying a used saw. This saw here is a good example of a bad saw. It's a bucking pattern, but you'll see that it's extremely rusty with significant pitting. The surface is very rough, and one of the problems with pitting is that you actually damage the structure of the teeth so that you can break teeth off when you're setting it. When you're looking to purchase a saw, avoid saws that have a lot of pitting on it like this. Other things to look for when purchasing a saw are your tooth length. You want a tooth that has quite a bit of length on it, at least an inch and a quarter long, because a longer tooth like that will give you more filings for your saw. Other things to look for are broken teeth. If you have 1 or 2 broken teeth in a saw, that's not particularly significant, especially if they're towards the end of the saw. But if it has a lot of them, especially if you have a number of broken raker teeth, then definitely avoid a saw like that unless you want to use it for a painter. One single broken tooth like this really is not going to have a whole lot of significance in how the saw cuts. And it can be adjusted for in how you adjust the height of the adjacent rakers if you do have a broken tooth on it. As I mentioned, the older saws, the better made saws are taper ground. That's another characteristic that can be used to determine whether or not a used saw is of good quality, is you can, by looking at the end of the saw, here if you just look end on, you can often see whether or not a saw is tapered. If it's a flat ground saw, I would steer clear of it, because those are generally not as good a steel in them.